Neuroplasticity. Brain health unlocked. Abstract. Neuroplasticity is the brain's extraordinary ability to generate new connections and change old ones. This affects brain development, learning, memory, and healing. This study discusses neuroplasticity's mechanisms, brain health benefits, and ways to maximize its potential. Neuroplasticity helps people practice brain health and cognitive well-being. This paper emphasizes the necessity of neuroplasticity for lifelong brain function. Table of contents. Introduction. Neuroplasticity basics. Structural plasticity. Functional plasticity. Neuroplasticity mechanisms. 3.1 LTP. Long-term depression, limited. Synaptic pruning. Brain development and neuroplasticity. Early life neuroplasticity. Adolescent neuroplasticity. Age and neuroplasticity. Learning neuroplasticity. Learning and memory, neuroplasticity. Learning and neuroplasticity. Brain disorders and neuroplasticity. Neuroplasticity and stroke. TBI and neuroplasticity. Neurodegenerative disorders. Enhancing neuroplasticity. Physical exercise and neuroplasticity. Cognitive stimulation. Neuroplasticity and mindfulness meditation. Neuroplasticity and nutrition. Brain health through neuroplasticity. Recovery and neurorehabilitation. 8.2 Mind fitness. 8.3 BCIs and neuroplasticity. Directions and obstacles. 9.1 Neuroimaging advances. 9.2 Ethics. 9.3 Neuroplasticity interventions for all. Conclusion. Introduction. The introduction discusses neuroplasticity, its history, and its impact on brain health and cognition. It introduces the paper and its sections. Neuroplasticity basics. This section introduces neuroplasticity. It discusses structural and functional plasticity, which involve brain architecture alterations and function redistribution. Neuroplasticity mechanisms. Neuroplasticity's cellular and molecular mechanisms are examined here. Synaptic plasticity involves LTP and limited. Synaptic pruning, the removal of unused connections, is also explored. Brain development and neuroplasticity. This section discusses neuroplasticity throughout brain development. Early neuroplasticity affects learning and cognition. Experience changes the brain's neuroplasticity. It encompasses the brain's ability to modify, reorganize, or develop neural networks. Brain damage or learning can cause functional or structural changes. The brain's plasticity does not mean it is plastic. Neurons are brain and nervous system building blocks. Neuroplasticity lets nerve cells adapt. Neuroplasticity types. Early researchers assumed neurogenesis, or the formation of new neurons, halted shortly after birth. 1. The human brain has about 100 billion neurons. Brain plasticity. Well, Junior B. Today, neuroplasticity allows the brain to reorganize pathways, make new connections, and even produce new neurons. Neuroplasticity has two types. Functional plasticity allows the brain to transfer functions from damaged areas to undamaged parts. Learning causes structural plasticity in the brain. Neuroplasticity works. Early brain development is quick. Every cerebral cortex cell has about 2,500 synapses, or nerve impulse relaying gaps, at birth. By 3, each neuron has 15,000 synapses. 2. The average adult has half as many synapses. Why? Because new experiences enhance and destroy some ties. Synaptic pruning occurs. Frequent use strengthens neuron connections. Non-users perish. The brain adapts by making new connections and removing weak ones. Neuroplasticity benefits. Neuroplasticity has various advantages. Brain adaptability promotes 3. Learning ability. Cognitive enhancement. Stroke and TBI recovery. Restoring lost function. Brain fitness boosting changes. Neuroplasticity traits. Neuroplasticity has several traits. Age and environment matter. Plasticity occurs throughout life, however certain changes are more prevalent at various ages. As the brain develops and organizes, it changes a lot in early life. Young brains are more sensitive and responsive to events than older brains. 4. However, adult brains can adapt. Genetics also matter. Environment and genetics affect brain plasticity. 5. Neuroplasticity continues. Glial and vascular brain cells undergo lifelong plasticity. Learning, memory formation, and brain injury can cause it. New research shows that the brain never stops learning. 6. Strokes can impair brain areas that control specific processes. Healthy brain regions may take over those functions and regain abilities. 7. Limited brain plasticity. However, the brain's plasticity is limited. Specific brain regions control specific actions. Movement, language, speech, and cognition include brain areas. While some healing may be possible, other brain areas cannot totally take over the functions impacted by brain damage. 8. Improve neuroplasticity. You can help your brain change at any age. Enrich your environment. Focused attention, novelty, and challenge in learning situations improve brain function. Enriching your environment is crucial during childhood and adolescence, but it can also benefit your brain in adulthood. 9. Brain stimulation could mean language acquisition, instrumental training, travel and discovery, artistic endeavors, reading, rest well. Sleep helps brain dendritic growth. 10 Dendrites are the growths at the ends of neurons that convey information. Stronger connections may increase brain plasticity. Sleep affects mental and physical health. Genetics and brain gray matter may be responsible for this. 11. Sleep hygiene improves sleep. This includes setting a sleep regimen and generating a restful environment. Regularly exercise. Exercise benefits the brain. Exercise may prevent neuron loss in important parts of the hippocampus, 12, which is involved in memory and other processes. Other studies suggest exercise helps create new neurons in this region. 13. A 2021 study found that physical exercise increases brain plasticity through affecting brain-derived neurotrophic factor, BDNF, functional connectivity, and the basal ganglia, which controls motor control and learning. 14. The U.S. Department of Health and Human Services suggests 150 minutes of moderate-intensity cardio, walking, dancing, swimming, or cycling, and 2 days of strength training, lifting weights or doing bodyweight exercises. 15. Be mindful. Mindfulness involves focusing on the present without thinking about the past or future. Observing your surroundings is crucial. Mindfulness increases brain neuroplasticity, according to many studies. 16. Play. Board, card, video, and other games can boost neuroplasticity. 17. 18. Neuroplasticity issues. Brain changes aren't always beneficial. Brain structure and function can be negatively affected. Brain plasticity can lead to harmful alterations caused by substance use, sickness, or trauma, such as brain injury or PTSD. Lead toxicity impairs brain plasticity. 19. Some medical diseases impede brain plasticity. They include epilepsy, cerebral palsy, tuberous sclerosis, and Fragile X syndrome in children. 20. Discovering neuroplasticity. Brain hypotheses have changed over time. Early researchers thought the brain was fixed, but contemporary study has proved it is more malleable. Early theories. Researchers believed brain changes only occurred during infancy and childhood until the 1960s. Early adulthood believed the brain's physical structure was essentially permanent. In his 2007 book, The Brain That Changes Itself, Stories of Personal Triumph from the Frontiers of Brain Science, psychiatrist and psychoanalyst Norman Doidge suggested that this belief that the brain was incapable of change stemmed from 3 main sources. 21. An old notion that the brain was like an exceptional machine, capable of amazing things but unable to alter. Inability to see brain activity microscopically. The finding that brain-damaged persons rarely recovered. William James, a psychologist, hypothesized that the brain might change. In 1890, in The Principles of Psychology, he said, organic matter, especially nervous tissue, seems endowed with a very extraordinary degree of plasticity. 22. This theory was ignored for many years. Modern theories. Carl Lashley found rhesus monkey brain circuit alterations in the 1920s. By the 1960s, researchers started studying elderly persons who had severe strokes and recovered, showing that the brain was more pliable than previously thought. Modern research shows that the brain can rewire itself after damage. 23. Modern research shows that the brain creates and alters neural networks to adapt to new experiences, learn new information, and develop new memories. Researchers can now see inside the brain thanks to technology. Modern neuroscience has shown that people can learn new skills and that damaged brains can change. 24. Very well says. The brain changes throughout life, allowing us to learn new things or recover from brain injuries. Brain adaptability is limited. Brain plasticity can be improved by pushing oneself, prioritizing sleep, and exercising. Avoiding some substances helps too. Why neuroplasticity? Learning and improving brain function require neuroplasticity. Neuroplasticity improves brain injury and sickness healing. Neuroplasticity examples? Children with blindness have increased connectivity and reorganized neurocircuits compared to children without this condition. 25. This suggests that the brain adapts to the inability to see by changing its structure and function, allowing them to use other senses like hearing and touch. Why neuroplasticity? Learning and improving brain function require neuroplasticity. Neuroplasticity improves brain injury and sickness healing. Please like, share, and subscribe.